So today we're doing lesson 5.3. So far, we have solved systems of linear equations by what two methods? Can anybody raise your hand and tell me the two methods that we've used so far? All right, I heard graphing and I heard substitution, and those are the two ways that we have learned. All right, let's break this down just a little bit. Systems of linear equations. How many equations have been in our problems? Two equations. And linear equations, when we graph them, they are what kind of graphs? What do they look like on the coordinate plane? They're lines, okay? So if I'm solving systems of linear equations, what am I looking for in my final answer?
Two sets.
No, go back and look. Go back and look at lesson 5.1. We wrote down a definition for the solution of a system. So go back to lesson 5.1 and look at what the solution of a system of equations actually is. Solution is a point of intersection. Where do my two lines on a graph intersect each other? So every single time we have solved, whether it's by graphing or substitution, your final answer is a what?
Point of intersection.
Okay, but it's a what? It's an ordered pair. Okay, if it's a point of intersection, it's an ordered pair. Points are written as ordered pairs. All right, so we're going to do the same thing, except in order to find that point of intersection, we're going to use a new method called elimination. All right, here's what we're going to do. Step number one, really simple. We're going to make sure that our x terms, our y terms, our equal signs, and our constants are all lined up vertically. So basically, we're going to make sure that our equations are written in standard form, and we're going to make sure our x terms, our y terms, our equal signs, and our constants are all lined up. Now, step two is where the bulk of the work is. In step two, or for step two, we're going to choose which variable we want to eliminate. Now, make sure when you're choosing a variable that is an x or a y, okay, in these problems. So make sure you're choosing which variable you'd like to eliminate. Then you have to multiply each equation by the number that will make the two terms opposites of each other. Now, let's talk through this. If you want to eliminate the x variable, let's say you're looking at a problem and you want to eliminate the x variable, and the first x term in the first equation is a 2x. What is the opposite of 2x? Negative 2x. So the only way that I'm going to be able to eliminate the x terms is if one of them is positive and one of them is negative. The only way I'm going to be able to eliminate the x term is if they both have the same coefficient. So do you see how they both have a coefficient of 2, but one is positive and one is negative? All right, and that is the key to elimination. Now, once you've solved for whichever variable you left, then you will plug the value of the variable into either original equation. Now, make sure you pay attention to that. Once you solve for either x or y, you're going to take that answer and go back to your original equations, okay, those equations that you didn't multiply anything by, and that's where you're going to plug your answer. All right, now, let's look at example 1. It says use elimination. If it tells me what method to use, I cannot pick graphing and I cannot pick substitution. This tells me to use elimination, so I have to use elimination. All right, now let's look at letter A. Remember, if I am trying to eliminate a variable, then I am looking for a variable that has are opposites of each other. So if you're looking at letter A, does any or either variable jump out at you as really all ready to be eliminated?
3x.
Okay, 3x, right? And negative 3x. If I look at them, they both have a coefficient of 3, and then one of them is positive and one of them is negative. So letter A is really very simple, and I would tell you, always look for that first. Okay, always look for the variable that may already be set up to be eliminated, because that is going to make your life so much simpler. So let's go ahead. What is 3x minus 3x? 0. Awesome. Okay, and then we combine things vertically. What is 2y plus 4y? 6y equals, what is 7 plus 5? 12. Now, we're solving simple equations here. So, Carson, how am I going to solve for y? Divide both sides by 6. So, Carson, what does y equal? 2. Now, circle, don't box, because remember, my final answer is supposed to be an ordered pair. So I've got to find the x coordinate. I found the y coordinate. I got to find the x coordinate. Now, this is step 3. I take what I solved for and I plug it back into one of the original equations. Does it matter which original equation? No. Okay? One person can choose the first one, somebody else can choose the second one, and you still should get the same x value. So Avery, would you like to plug it back into the first equation or the second equation?
The first one.
All right. So we're going to bring down 3x plus 2 times. I'm going to go ahead and plug that 2 in there in place of y, and it equals 7. So 2 times 2 is 4. Now, here we are again, chapter 1, solving equations. So, don't call me after midnight if you're stuck and you don't know what to do. I don't have the distributive property. I don't have like terms to combine. I don't have a variable to move. So I'm down at after, which is add or subtract. So Luke, what am I moving first if I'm trying to get x by itself? I'm going to subtract 4. Awesome. So that cancels. I'm left with 3x equals 7 minus 4 is 3. And Luke, what would I do to finish this problem?
Divide.
Both sides by?
3.
Awesome. So what does Luke x equal? 1. Again, don't box it. Circle it, but don't box it. But now we've solved for x and we've solved for y. So Amelia, what is my final answer? 1, 2. Remembering that when I write an ordered pair, the x coordinate is first and the y coordinate is second. So my final answer is 1, 2. That means if I were to graph those two lines, they would intersect at the ordered pair 1, 2. All right, any questions so far? All right, now let's look at letter B. Again, we have options. So let me give you some tips. First of all, if you're looking at letter B, do you see any variable that is already ready to be eliminated? No. There is no variable. Okay, just yes or no. Just yes or no. Is there any variable that is completely ready to be eliminated? No, right? Because I don't have the same coefficient and I don't have one that's plus and one that's minus. So I don't have anything that looks like letter A did. However, when I am choosing which variable I want to eliminate, here's what I'm looking for. First thing I'm looking for, is there at least a variable where one's already plus and one's already minus? Because if so, that's the one I want to eliminate. And here's why. I'm getting ready to have to multiply either one or both equations. So I want to be able to multiply by positive numbers. So if I can find a variable that at least the signs are already different, that's the variable I'm going to choose. Okay? Here's the other thing I'm looking for. I'm also looking for a set of variables that maybe at least one of them has a coefficient of 1. Because if one of them has a coefficient of 1, then I'm only going to have to multiply one of my equations instead of both of them. So that's some tips. Again, if you don't understand what I just said and you just want to randomly pick, please feel free to randomly pick. But I personally, if I'm looking at letter B, I'm going to eliminate y. And I'm going to eliminate y because one of them is negative and one of them is positive. Now, this also falls into my other category. What is the coefficient of the second y term? 1. So it falls really into both of my categories. They're already different signs, and one of them has a coefficient of 1. So I'm going to eliminate y. Now, in order to do that, I'm going to have to multiply one or both of these equations. So look at 1 and look at 3. We'll forget the signs for just a second because we already know they're different. Let's look at 1 and 3. In order for me to be able to eliminate y, I got to get those coefficients to be the same. So I need a common multiple of 1 and 3. Now, don't start shouting answers at me, okay, but listen to let's remember and review multiples. I'm not looking for factors. Factors fit into numbers. Multiples keep getting bigger. So if I'm looking at the bigger coefficient, which is 3, what are multiples of 3? Well, what is 3 times 1? 3. What is 3 times 2?
6.
What is 3 times 3?
9.
So 3, 6, 9. Those are my multiples of 3. So my question is, what is a common multiple? And somebody raise your hand. What's a common multiple of 1 and 3? Somebody raise your hand.
3.
Okay. Travis. 3. Does everyone agree with that? Does 3 times something give me 3? 3 times what gives me 3? And 1 times what gives me 3?
3.
So is 3 a common multiple of 3 and 1? Absolutely it is. All right. So now I have to decide if my common multiple is going to be 3, which equation do I have to multiply by? Do I need to multiply the first equation, or do I already have the common multiple? I already have the common multiple. How many of you would agree with that? By a show of hands. Okay. How many of you have no clue what I'm talking about? Okay. Awesome. So I don't need to do anything to the first equation because it already has the common multiple of 3. What am I going to multiply the second equation by? Because 1 times what will give me the 3 that I need? 3. So I'm multiplying the second equation by 3. Okay? If I have to change the y coefficient to a 3, 1 times 3 is going to give me that 3. Now, like I said, the signs are already different, so I just multiply by a positive 3. Which means I'm moving that first equation down and I'm not changing anything about it. X minus 3y equals 24 does not have to change. So I just bring it down. Now be very careful. When you're multiplying an equation, you are multiplying every single piece of that equation. Every single piece. So in your notes, I want you to draw those arrows. So when you're looking back, you know exactly what you multiplied by. So what is 3 times, Layla, what's 3 times 3x? 9x. What is 3 times y?
3y.
Positive 3y. And what is 3 times 12? 36. Now, can I eliminate the y?
Yes.
Yes or no, class?
Yes.
Yep. I got a negative 3y and a positive 3y. So I cross it out and I solve for x. What is x plus 9x? 10x. Loza, what is 24 plus 36? 60. And Loza, how do I finish solving for x? Divide both sides by 10. So x equals 6. Good. Now, pick one of your original equations and plug the 6 back in and see what you get for y. All right, we're going to pick the second one. We're going to plug 6 in for x. So we have 3 times 6 plus y equals 12. 3 times 6 is 18 plus y equals 12. Jaden, how'd you solve for y? We're going to subtract 18. So y equals negative 6. Very good. So our final answer, Jaden, is what? 6 comma negative 6. So if we were to graph those two equations, they would intersect at 6, negative 6. All right, any questions? Awesome. Now with your table, I want you to work on letter C. Let's see what you guys come up with together. All right, now we can tell right off the bat with letter C, are either variables ready to be eliminated right now? No, they're not. All right. So again, we're looking for, first thing I look for is at least one of them positive and one of them negative. Do we have any set of variables where one's plus and one's minus? No. All right. So now we're looking for, do we have any that at least have a coefficient of 1? Yes. Okay. And in this problem, really, we've got both of those. If I'm looking at my x terms, I've got one that's a coefficient of 1. If I look at my y terms, I have one that's a coefficient of 1. So really, there's definitely no right or wrong choice here. So JC, what did you guys pick at your table? Did you want to eliminate x or did you want to eliminate y? Okay, they chose to eliminate x. Which means, JC, what is the understood coefficient of x?
1.
Is 1. So what was your common multiple of 1 and 4? 4. So you had to multiply which equation and by what?
4x plus y.
But which equation? You multiplied by 4. And which equation did you multiply by 4? Tell me again which equation you guys multiplied. Did you multiply the first, the second, or both?
Both. Or that first.
The first one, right? If I multiply the first equation, and for this problem, I'm just going to stick it here at the back. Okay, it doesn't matter. I can put it at the front. I can put it at the back. But remember, I'm multiplying all parts of the equation by that 4. Now, JC, before we do this, though, you're going to multiply by 4, but your signs are the same. So instead of multiplying by a positive 4, you're going to have to multiply by what kind of a 4?
Negative.
a negative 4. So remember, if your signs are the same, they can both be plus, they can both be minus, but if your signs are the same, when you multiply by a number, you're going to have to make it negative. Because remember, our signs have got to be different. So we multiply everything through, and I'm going to bring down the equation that didn't change. So I'm bringing down 4x plus y equals 13. So JC, when you guys multiplied through by negative 4, what did you get?
Negative 12.
You multiplied everything by negative 4. Give me the new equation.
Negative 4y.
But what about negative 4 times x? What does that give me?
Negative 16.
Listen, I'm going all the way back to the 1x. So what's negative 4 times 1x?
Oh, negative 4x.
Negative 4x. Then I'm going to do the negative 4 times the 4y. What does that give me?
Negative 16.
Negative 16y. And it's going to equal what's negative 4 times 22?
Negative 88.
Negative 88. Now I can eliminate my x because 4x minus 4x is going to be 0. All right? Loza, what was y minus 16y?
Negative 7.
Are the signs the same? That's a positive 1 y and a negative 16. So negative 15y equals what's 13 minus 88? Loza? Negative 75. All right? And to finish solving for y, Kayla, I had to do what?
You had to divide negative 15 by this.
Good. I'm going to divide both sides by negative 15. So y equals? What's negative 75 divided by negative 15? 5. Good. Circle, don't box. Now, I've got 5 for y. Where do you want to plug it, Blake? Which equation do you want to plug it into? We're going to plug it into the first one. So x plus 4 times y, which was 5, equals 22. X plus 4 times 5, which is 20. And how do I solve for x, Blake?
You have to subtract 20.
Good. I'm going to subtract 20 from both sides. So x equals 2. So my final answer, what is that ordered pair? My final answer is what? Blake?
2, 5.
2, 5. The ordered pair, 2, 5. All right. Now, for those of you that are still a little bit confused, let's look at letter D. All right. We're going to go through this one just as slowly. Okay. So you can try to pick up what we're doing. Now, we're looking at our x terms and we're looking at our y terms. So we have 3x and 2x. That's one set of terms. Or we have 4y and negative 5y. So do either of those have the characteristics that I taught you to look for? I would disagree. Remember, if they're not completely ready to eliminate, we're at least looking for a set that maybe has a coefficient of 1 in one of them, or that already has opposite signs. Because if we can find one that already has opposite signs, multiplying is going to be easier. So let me ask that question again. Do you see either set of variables that has one of those shortcuts that we talked about?
Yeah.
Which one?
4y.
There you go. There's 4y and there's negative 5y. Now, would it be wrong to try to eliminate the x's? Absolutely not. But if we're trying to make our lives simpler, I'm going for y because at least one's positive and one's negative. All right, now Blake, if I'm looking at 4y and negative 5y, 4 and 5 essentially are my coefficients. What's a common multiple of 4 and 5?
20.
Okay, so I need to multiply the 4 by what to get 20?
5.
So I'm going to multiply the entire first equation by 5. Now, Blake, I need the second equation to also be a 20. So 5 times what is going to give me 20?
4.
So the second equation has to be multiplied by 4. And since the signs are already different, I can multiply by a positive 5 and a positive 4. Okay? So Blake, multiply the first equation through by the 5 and tell me the new equation.
15x plus 20y equals 30.
Okay, perfect. And multiply the second one through by 4 and tell me what you get.
8x minus 20y equals negative 76.
Awesome. Now, which one of those can we eliminate? The x's or the y's?
The y.
The y's. 20y minus 20y is 0. So 15x plus 8x is 23x. And 30 minus 76 is negative 46. So how do I finish solving for x?
Divide by 23.
Divide both sides by 23. And so what does x equal? Anybody? What's x equal?
-2.
Negative 2. Awesome. All right, now, we've got a choice to make. Nate, where do you want to plug the negative 2? All right, he's going to plug it into the first, so that's 3 times negative 2 plus 4y equals 6. So that's negative 6 plus 4y equals 6. Nate, what would you move first? The negative 6 or the 4?
-6.
Okay, how do we move it?
Yeah, it's 6.
We add 6 to both sides. So we get 4y equals 12. And how do you finish this one? Nate?
You divide and answer is 3.
Okay, I divide both sides by 4, and my answer is 3. Now, final answer, Tristan. If x is negative 2 and y is 3, what is my final answer? The ordered pair, negative 2, 3. Look at the word problem. We're going to write and solve a system of equations using elimination. It says a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans. So what variable can we use to identify large and small? All right. So 5 large. Now why would I multiply the 5 and the large? Okay? Because if I go on, it says for a total cost of $235,000. Okay? So why would I take 5 times an L? What does the L represent? The cost of the large vans. How much do the large vans cost me? I know I'm getting 5 large vans and 2 small vans, so 2S, for a total of. That's how I knew to add the 2 terms together, because it's going to cost me a total of, so equals $235,000. Now that's location A. Look at location B. They received 2 large vans and 3 small vans. So what are their terms going to look like?
2 large, 2L.
Okay, 2L, hold on, 2L plus what, Malcolm? They got 2 large and 3 small. So 2L plus 3S. Awesome. For a total of, Deslin? $160,000. So it says, what is the cost of each type of van? So how much does a large van cost? How much does a small van cost? All right, Carson, would you like to eliminate the L or the S? All right, if she's going to eliminate the L, what is a common multiple of 5 and 2?
3.
I'm asking Carson. Carson, what's the common multiple of 5 and 2? 10. So the first equation has to be multiplied by what?
2.
Good, because 5 times 2 is 10. And Carson, if I want to turn the second L term into 10, it's going to be 2 times 5. Now, my signs, are they the same right now or are they different? They're the same, Carson. So, one of these numbers I'm going to have to make a what? A negative, because I need my signs to be different. Does it matter which one is negative? No. All right? So I'll just pick negative 2. Now, we're going to multiply each term in the first equation by negative 2, and what do we get, Carson?
Negative 10L
Mm-hmm.
plus 4 minus negative 4S.
All right, well, just minus 4s. If we say minus negative, we've got a double negative, and that's not what we have. Negative 2 times positive 2 is negative 4s. And it equals 235,000 times negative 2, which is negative 470,000. All right? Amelia, we multiply everything in the second equation by 5, and what does that give us?
10L plus 15S equals 800,000.
Very good, 800,000. Okay? So my L's cancel. What is negative 4s plus 15s? I get 11s. And if I do negative 470,000 plus 800,000, I am left with 330,000. So how would I solve for S to finish this problem? Caleb.
Divide 11.
Good. I'm going to divide both sides by 11. So what is the cost of a small van? $30,000. Now, why did I put a dollar sign? Because this is a word problem and I must label my word problem. So as long as you use an S, I would say box that in as your final answer. Now, if you chose X and Y, you would have to identify it costs $30,000 for a small van. But if you've used an S and an L, I'm going to be able to figure out that you're saying the small van is $30,000. Now, we got to plug that back in because we got to find the price of the large van. All right? So which equation, Daniel, would you like to plug this $30,000 into? Okay? So 5 times L plus 2 times, we're plugging 30,000 in there, is going to equal 235,000. So 5L plus 60,000 equals 235,000. All right, what am I going to do next to solve for L? Subtract 60,000. So I have 5L equals 235,000 minus 60,000, which is 175,000. And how will I finish this off? Divide both sides by 5. And the cost of a large van is 35,000. Now again, don't forget your dollar sign because we're talking about money. And if you've used L, I'm okay with you boxing in L equals because I'll know you're talking about the large van. If you chose a different variable though, you got to make sure that you identify what you have found. All right? And that is lesson 5.3.